Hey guys, welcome to another Theory of Computation tutorial. Today we'll be learning about Mealy Machine and Moore Machine. So let's get started. First thing, what are we going to learn? We'll look at different types of finite automata with output. Then what is Mealy Machine? We'll look at an example of it. Then we'll look at what is Moore Machine and an example of Moore Machine. All right. So let's get started. First thing, what are finite automata with outputs? So till now we have seen finite automata without output like this. So we have got state A, you get input 1, you go to state A itself, you get input 0, you go to state B. Similarly, in state B, you get input 0 or 1, you are going to state B itself. Okay. So over here, when we are getting some kind of input, you are just changing the states. So this is finite automata without output. But now we are going to look at finite automata with outputs. So there are two types of finite automata with output. First one is called Mealy Machine. Second one is called Moore Machine or Moore Machine. All right. Now what is Mealy Machine? So Mealy Machine consists of 6 things over here. First we have got Q. Now Q is a finite set of states. Okay. Then we have got our sigma, which is set of input alphabets. Then we have got delta, which is set of output alphabets. Then we have got del. It is a transition function. That is, if you are in state A, you get input alphabet 1, you go to which state. So this is known as transition function del. Then we have got our lambda. Now lambda is output function. That is, on getting what input in which state, we are going to get what output. So this is known as output function. And Q0 is the start state or initial state. All right. Now let's look at an example of Mealy Machine. So let's say, So let's say we are in state A. Okay. You get input 0. Then you're going to get an output of A and you're going to go to state B. Okay. So remember, we have got a starting state A over here. Okay. Then you get an input of 0. Okay. And you're going to state B. Okay. And you're getting the output A. Understood? So over here, you're not just changing the state, you're also getting some kind of output. Okay. Similarly, you're in state A, you get input 1. You're going to state A itself, but you're getting an output small b. So these are output letters A and B. Okay. And these are input letters or alphabets 0 and 1. Okay. So understand it now. Let's say over here with the same example. So Q is a set of finite state of state. So what does that mean? It means Q consists of A and B, capital A, capital B. It is set of finite states. Okay. What about set of input alphabets? As we have seen, we are giving input of 0 and 1, correct? Then we have got our delta over here. Delta is set of output alphabets. What were our output alphabets? We had A and B, correct? Small a, small b. Then we have got transition function Q multiplied by our output, Q multiplied by, that is whatever state you are in. Let's say you are in state A, you get an input of 0. You are going to go to state B. So this is our transition function. And output function is, let's say you get an input 0 and you are in state A. Then you're going to get the output as, we had the output as, I think it was small a. Let's see. Yeah. You get input 0, you go to state B, but the output was A. Okay. So this is our output function. And Q0, as we know, is the starting state or initial state. So over here, let's say our starting state is A. So this is what Mealy Machine is. Over here, you're not just changing the states, you're going from one state to another and you're getting a different output also. Okay. So in Mealy Machine, the output, that is the alphabet, is dependent on the starting state as well as what the input alphabet is going to be. Okay. So just a second. Yeah. So we were giving input alphabet as 0 over here and our starting state was A. And since we got the output alphabet as small a, we have written it over here, small a. Okay. So the output is dependent on the state as well as the input that you are giving. Okay. All right. So let's look at an example. So let's say, to remember this, imagine there's a traffic police standing over here, and depending on how many vehicles are there, okay, on the road, he is going to manage the traffic. That is, let's say an emergency ambulance is going, he's going to stop other cars based on what the input he is going to get. That is, if there is a lot of cars on one side of the road, then he is going to first clear out that side, and then on the other side where there are very less vehicles waiting, that vehicle he'll stop for a little bit longer time. Okay. Or For example, there are some school children who want to cross the road, then he's going to stop the traffic on this side so that the children can cross. So depending on the input and what current state it is, the output alphabet is changed. Okay. Now, what is Moore machine? So Moore machine, as we have seen, Mealy machine, similarly, this one also has 6 things. Okay. First, as we know, is a queue. Queue is the finite set of states. Okay. Then we have got our sigma, which is set of input alphabets. Then we have got set of output alphabets, delta. Then we have got del, that is transition function. So till here, out of all these 6 things, 5 things are common. Only the output function is different. Now, what is output function? Output function means that the output state is only dependent on your current state or the states. It is not dependent on the input alphabet. Okay. So let's look at an example to understand it. So let's say you are in state A. If you are in state A, the output letter that you're going to get or output alphabet you're going to get is going to be A, small a. Okay. And if you're in state B, then the output alphabet that you're going to get is small b. Okay. So let's say you're in state A, you get input 1, you go to state A itself, and the output is going to be A. Okay. If you are in state A, you get you get input 0, you go to state B. Okay. And you're going to get the output as small b. So the output is not dependent on your input alphabet. It is only dependent on the states. Okay. So as we can see over here, we'll just write it down. So we have got our finite set of states over here. So it is capital A comma B. Then we have got set of input alphabets. What are set of input alphabets? We have got input as 0 and 1. Then set of output alphabets, it is going to be A comma B, small a comma small b. Then we have a transition function over here. That is, if you're in state A, let's say you're in state A and you get an input 0, you go to state B. Okay. You go to state B. Okay. So this is our transition function, and output function is, it only depends on the states. So if you are in state A, the output is going to be small a. If you are in state B, the output is going to be small b. And Q0, as you know, it is the initial state or starting state. Okay. Now, to understand this or to remember Moore machine, imagine instead of a traffic police, it is automatic traffic lights. Okay. So if you are currently you are in go, that is green color state, then since it's in green color, automatically it is going to go to your yellow color, then it is going to go to red color. And if you are in red color, it is going to come back to green color again. So this function is not dependent on the traffic. It is not dependent on the how many vehicles are waiting or what. It is just going to be pre-programmed already with let's say 30-second timer or 1-minute timer, and on currently which state it is going to go to the next state. So it won't go from green state to red state directly. It is going to go from green state to your yellow state, and then from yellow state to red state, and from red again it is going to come back to green state. So it is totally dependent on which state you are. The output is going to be dependent on that. So this is the example of Moore machine. Sorry, it should be Moore machine. Yeah. So it's like this. No matter what traffic situation is over here, it is going to be pre-programmed on what current state it is. It's in green state, it's going to go to yellow state after that. And if it is in yellow state, then it is going to go to red state after that. It is only dependent on the current state. The output is dependent on that. All right. So now if we compare Mealy machine and Moore machine, let's say we pass a string 1010. Okay. So let's say you are in, how does that work? So let's say you are in state A. Okay. You get input 1. You are going to go to state A. So this is our Mealy machine. Okay. So 1010. Okay. So this is our states, and this is going to be our output. All right. So you're in state A, you get input 1, you go to state A itself. Okay. And you're going to have the output of 1. Sorry, you have the output of B. Correct. You are in state A, you get input 1, you go to state A itself, and the output is B. Okay. Then you have got 0. You get 0, you go to state B. Okay. And you get the output as small a. Okay. Then you have got input 1. You are going to be in state B itself, and you get the output alphabet as A. Okay. And in state B, you get input 0. You go to state A. okay, and the output alphabet is going to be B. Okay, so here as we can see, this is the output, and if you pass the same string to the Moore machine 1010, so let's say you are in state A currently. Okay, you are in state A. As you're already in state A, there is already an output alphabet over here, which is small a. Correct. Now in state A, you get input 1, you go to state A itself. Correct. Input 1 you go to state A. Correct. And you are in state A, so again the output alphabet is A based on the state itself. Then you get input 0 again after this. Okay. And you go to state B. And in state B, you get the output alphabet as small b. In state B, you get another input 1. You come back to state A. Come back to state A, and state A, the output is going to be A, small a. And in state A, you get input 0. You go to state B again. State B. And in state B, the output is small letter b. So as we can see over here we had, based on the string 1010, it had 4 numbers. We have got the output of the same length as the string, but over here we have the length n plus 1, because the starting state already the output was coming small a, because you are already in starting state and the output is dependent on the state itself. That's why we have got over here 4 plus 1, that is equal to 5 output alphabets. So this is how we compare Mealy machine and Moore machine. So I hope you got this concept. If you have any queries, feel free to ask me in the comment section below. Thank you very much.
So that's it for today, guys. Thank you very much for watching. If you have any queries, feel free to ask them in the comment section below. If you have any suggestions, please write them in the comment section below. If you like the video, please share it with your friends and subscribe to my channel. Thank you very much.